All right, so this is the second part of the two-part video on suspected limb lead reversal. And I know I've talked about this once already, but I feel like I got to talk about it again just because it was an interesting thing that happened. If you need the background on this particular EKG that we're looking at, then check out the first video in the series, and I'll try to link them together here. But otherwise, let's go on. Let's talk about limb lead reversal itself. In order to understand that, you kind of got to know, well, how an EKG gets born. So you essentially have three leads. You have one that's labeled RA, one that's labeled LA, and one that's labeled LL. And those are just three. When I say leads, I mean those are three electrodes that you have hooked up to a computer box that does some magic with electricity and figures out the current running between those things. So when you measure the current between lead RA or electrode RA and LA, you generate a line that looks like that. And we call that lead one. And that's what displays in lead one. Likewise, when you measure the current between RA and LL, those again are the electrodes. No matter where you put them, that's what's being measured. You call that lead two, and then LA to LL, the difference in current between those two, or the difference in voltage between those two, is termed lead three, and that's just the convention that we write. Now you can also do some stuff with electricity, and it's really fairly simple. But you can generate the augmented limb leads as well, which when you draw a line between lead RA and lead LL, you call that AVL. If you take the midpoint of that line and essentially point it towards the left arm, it goes in a direction like that. If you take the one that travels along lead 3, or the midpoint between LA and LL, and draw a line toward the RA electrode, then you generate AVR. And if you do the same thing for RA to LA and then point it towards the feet or the LL lead, then you get lead AVF. All right, a little bit complicated. Maybe watch it again. Go back and think about how you're generating an EKG. But this is the triangle. This is the way that you generate the leads, the direction that all the current is being measured in and where it comes from. So by the way, there's also, when people say, oh, I got a 4-lead EKG. The fourth lead is a ground. It's not participating. You're only generating 3 leads. That's what the EKG is. You're only using 3 leads. The ground is just there to kind of help out. But RL doesn't participate, just FYI. But you can still screw it up if you misplace it a little bit. But anyway, let's talk what happens if you were to reverse lead. By accident, you stuck the electrode labeled LA onto the patient's right side and RA onto the patient's left side. You put, you got the colors backwards, you weren't paying attention, or maybe it's all kind of wiped off and you just kind of stuck them on there. What do you get? Well, so the left side is the way that it normally is for reference. The right side in this graphic is the way that it's going to be if you reverse those things. So we switch those 2 electrodes. And what does that do? Well, we take lead 1. Lead 1 is measuring from RA to LA. And in this case, RA is over here instead of over here. So that flips over. Then we know that lead 2 by definition is the difference between RA to LL, which is now over here instead of over here. So we'll call that lead 2, and then LA to LL is lead 3, which is now over on this side. So what you've essentially done is flipped lead 1 over. It's going in the opposite direction, so it flips over, and then you switch places. Lead 2 and lead 3 switch places. There again, 2 would be what's supposed to be where 3 is, and 3 is supposed to be where 2 is. And that's what you demonstrate on that EKG. Lead 1, if you do that, looks flipped over from the correct way. Lead 2 and lead 3, essentially those tracings switch places. And 3 looks like 2 and 2 looks like 3. That's if you reverse the RA and RL leads, RA and LA leads. And this is probably the more common thing that you're going to see, because they usually don't mess up the leg lead, at least in my experience. But folks get the right side and the left side switched all the time. Let's look at the augmented limb leads real quick, just to demonstrate that the same thing would happen, because again, you are changing the direction of the leads. So we've already flipped over the LA and RA lead. So by definition, the vector going from the middle of lead 2 up to the LA electrode is called AVL, and normally it points that way. In this case, it's going to point that way. Again, by definition, we call the signal from the middle of lead 3, or the path of lead 3 right here, or in this case right here in the normal one, point that toward the RA electrode, and you get AVR. So normally it would look like that. It flips kind of over in this way, still going the other direction, excuse the graphic. And then lead AVF is determined to be the midpoint of lead 1 pointing down toward the left leg, or toward the feet, essentially. And so that actually will stay about the same, because lead 1 is still here, lead 1 is still here, even though it's the same direction, but it's perpendicular to it, so it doesn't care. So AVF is going to say essentially the same. Makes sort of sense. Maybe it doesn't. If you sit down and kind of think about it and write it out, though, it just might. And in fact, I don't remember this pattern. I don't remember to tell you, like, oh yeah, if RA and LA switch, then you lead 1 flips, and then 2 and 3 switch places, and AVR and AVL switch places, and AVF stays the same. I don't remember that because it's not worth committing to memory. It doesn't happen that often. But when I see something funky, I sit down, get a repeat EKG number 1, assuming the patient's okay, and then I sit down and actually write it out, and I find that stuff is exactly what happened. So when we look at this EKG again, what do we see? We see again, the one on the left is the repeat EKG, or the correctly placed EKG. The one on the right is the one that suspected limb lead reversal, and in fact it is classic for what a right arm, left arm limb lead reversal would look like. So lead 1 flips over. You got pointy thing pointed down, now pointy thing pointed up. Lead 2 and 3 switch places. That 2 looks fairly similar to that. That 2 looks fairly similar to that 3. So 2 and 3 switch places. Instead of that one being on the top, it's on the top here. Or instead of that one being in lead 3, it's in lead 2. And instead of that one being in lead 3, it's in lead 2. Say the same thing twice, and hopefully everybody gets it. Yeah, anyway. And then AVR and AVL switch places. Again, same thing. Lead AVL looks a lot like that. Lead AVL in the old one looks a lot like that. So they just switch places, and AVF stays the same. Again, that's me kind of walking through it. It makes sense to me, but that's because I kind of sat and thought about it for a little bit. But it's really not that complicated. And is it something you're going to do, like while the patient's in the ambulance, like, wait, I got to make this determination, see if I screwed that up? No, you're just going to put the leads back on them. You're going to make sure it's in the right spot. And of course, you're going to go from there. And once you're sure it's in the right spot, then you'll do whatever, it comes up with it. But that recognition that if something looks funky on this EKG, if you get a wildly weird reading, the thing you should do is take the leads off, stick them back on, and make sure that the first thing wasn't us, kind of messing it up. And sometimes you find out that it is, and it's nobody's fault. We all make mistakes, but it can have major implications depending on what you see on that EKG and what you tell somebody about on it. And again, in fact, you don't have to remember the pattern. If you want to do it at the station afterwards, this is what I did because I had a minute sitting still in the emergency department when this was handed to me. I sat down and I wrote the thing out, and I don't remember the pattern. But the really nice thing about it is that once you grasp this part, this is really what knowing what an EKG is all about. This is when you've kind of understood it. So till this point, you're just doing kind of pattern recognition, but when you can tease this stuff out, when you can sit down and draw out the triangle and like figure out what happened and troubleshoot that based on what you're seeing just on the EKG and not on what the leads actually look like, that's when you know that you really understand it. So you may not understand it right now. That's okay. Keep working on it. Draw this stuff out. Think about it hard, and it'll become clear. Hell, it only took me 10 years of being a doctor to figure that out, and I just now figured it out. Anyway, that's what we got for now. Hopefully this is useful to you. Check us out again. Like, share, subscribe, do all that kind of nonsense, and stay safe out there. We'll see you later.